learners, and welcome back to our second lesson where we are going to be getting into the actual questions. If you forgot my name from last time, my name is Quinton Beckett and I am from Port Rex Technical High School here in the Eastern Cape. I just want to welcome you to ECDoE Broadcast Studio where today's lesson is being filmed, and today we're going to carry on with Euclidean geometry, and as I said before, we're going to be looking at two questions. Only two, because that is all the time that we have. Let's get into the content. Let's not waste any more time with that. As you can see in front of you, here is a question from last year's question paper from May-June 2024. And this was the grade 12 question. So question 7. Matrix, before you answer the question, read it at least 3 times. Don't just go through the question. Read through it, understand it, make notes, write things down. This is the best way to answer Euclidean geometry. Step number 2, don't look at the drawing and then just go blank, because that's what happens. You look at the drawing, and like I say to my students in my school, you look like a deer caught in the headlights. If you don't know what that means, it looks like this. You just stand there, frozen, scared. You don't know what to do. Stop, breathe in, relax. Look at the question, break it down. See if you can find the arrow theorem. See if you can find the bow tie theorem. See if you can find a tangent. Look to see how you can break the question down. If you look at it as a whole, I guarantee you are going to go blank. But if you look at it in individual parts, it's simple, it will be easy, and you will get free, what I like to call free marks. So let's have a look at the question and let's read it together. In the diagram below, O is the center of the circle. So we know there is O and it's in the middle. That already tells me some very interesting facts about the question or about the circle. Just very quickly off the top, that tells me that OW and OR are radiuses. Okay, why? Because it is a chord which is going from the center of the circle to the circumference. So let's just rub those down so we don't get too muddled up here with everything in there. Then we are told that R, S, V, and W are points on the circle. R, S, V, W. There they are. Be very careful. R, S, V, and W do not form a cyclic quadrilateral. Be careful. Just because they're on the circle circumference doesn't mean that it is a cyclic quadrilateral. Furthermore, we are told that RS and WV, told that RS and WV are produced to meet at T. A big, ugly, funny word just to say that those two lines go out and they meet outside at point T. RV and WS intersect at P. There's RV, there's WS, intersect, there they are, at P. And we are given 2 angles. We are given, let's get rid of that, we are given angle R, which is 20, or more specifically, we are given angle SRV, which is 20 degrees, and we're given ROW, which is 80 degrees. Matrix. I always tell my learners that Euclidean geometry is like an English set work story. You start with an introduction, you move on to the body, and you end with the conclusion. You don't go to the cinema and watch the ending of the movie and then try and rewind to go back to the beginning. It is the same with Euclidean geometry. You start with question 1 and you move your way from question 1 to 2 to 3 to 4. Question 1 will help you answer question 2. Question 2 into 3, and that's how it works. You cannot jump from question 1 to 4, back to 3, then to 5, back to 2. It doesn't work like that. You must follow the story plan. You must follow the pattern. So we go from our introduction into the body of the work, and then we move on to the conclusion. So in other words, what I'm saying is we need to start with question 7.11. And we need to find what is angle V1. Right, let's get into it. So, first things first, let us go to the drawing. And let's find where angle V1 is. So we go to the drawing, there is our angle V1. And like I said before, if you look at the drawing as it is there in its entirety, it looks like a huge dog's breakfast. It is an absolute mess. But if we start simplifying it, take a pencil, take a different color. Apologies, you won't be able to use colors in your final exam. Take a pen and highlight. What can you see? I can see an arrow over there. I'm going to change the color to blue. I can see another arrow over there. Okay, so already I can see that I have an arrow theorem staring at me. Be very careful. Make sure that you simplify. So let's answer that question. The question was, what is the size of angle V1? Very important how you answer the question. We say to the examiner, sorry, let's change that to black, and let's get rid of that quickly. There we go. We say that angle V1. Now, matriculants, I do apologize. My handwriting looks like I am a 4-year-old. I'm getting used to the system, so don't worry about that. I will try and make it as neat as possible. But I'm sure if my learners in my school at Port Rex can understand what I'm writing, you definitely will be able to as well. So here we go. Very important. Look how we write angle V1. Angle at the top, V1, little subscript 1 at the bottom, equals 2. We said that we had the arrow theorem. And the arrow theorem said to me that the angle at the center of the circle is 2 times the angle, is 2 times the angle of that at the circumference. In other words, if O1 is equal to 80 degrees, that tells me that angle V1 is going to be equal to 40 degrees. This is where I have a problem, because you go 7.1.1, done. And you move on and you say 7.1.2. You have just lost 1 mark. You did not tell me, or the examiner, the reason why angle V1 is equal to 40. Remember what we said earlier. Very important. You cannot write arrow theorem. The examiners will not accept, I want to change the color, will not accept that. It is incorrect. That is the slang version. You need to write the correct version. And what is the correct version? Let's get it out here in my pen. The correct version is that the angle, remember you don't have to write angle. If you want to, you can. You can write angle like that. The angle at the center. And please, American or English is fine. What do I mean? If you say ER or RE, the examiner is not going to minus marks for spelling. This is not English. So here we go. Angle at the center is 2 times angle at circumference. Oopsie. Thank goodness spelling doesn't count. And like I said, chicken scratch all over the show. That will earn you your mark, 100%. Don't worry if it's a little off here or there. The examiner, if they're worth their weight in gold, they will understand exactly what you've written. The angle at the center is equal to 2 times the angle at the circumference. Okay, moving on. Let's go and quickly delete all of that so we've got a nice clean page for us. And let's move on to question number 2. And question number 2 says to us that we need to find angle T So we go back to our drawing. Angle T is over there. Now, this is where I'm sure you've heard the saying before. There are many, many, many ways to skin a cat. And Euclidean geometry is exactly the same. Angle T, there's at least two ways or possibilities that we can solve that angle. There's a very quick way and there's a slightly longer way, but you will still get the same answer. The question is worth 2 marks. Only 2 marks. What I suggest you do is you try and save as much time as possible. Try and learn the most efficient, the best way to answer the question. In this case, the quickest way or the best way to answer the question is to say, hang on, there's a triangle. And this is an exterior angle of such triangle over here. So the quick way is that angle T is equal to 20 degrees. And we don't forget the reason. In this case, it would be EXT, exterior angle of triangle. Looks like hieroglyphics. But that is 100% correct. You will get full marks. You'll get 1 mark. Let's change the color quick. 1 mark, 2 marks. Right. Easy, easy. The long way. And I don't want to spend too much time on the long way. Let's get rid of all of this. Here we go. The long way is you can see, hang on, I've got triangles and I've got straight lines and I've got bigger triangles and smaller triangles. Can you see the next big triangle? There it is. Let's work through this one slightly quicker than the last one. We have one angle of this triangle. We know that angle R, in this case, is equal to 20 degrees. Right, we also know that angle S1 is equal to 40 degrees. Why? Angle at center is equal to 2 times angle at circumference. Okay, sorry, I'm running out of space there. Okay, so the S1 is equal to 40. Why? Because there's your 80, and we have our arrow theorem that goes through. Let's highlight it. There's our arrow theorem sitting over there. Therefore, we know that angle S2, can't use, no one's going to see yellow. Angle S2, yeah, go back. Hey, it's technology and the gremlins that jump out and we sort them out. There we go. Angle S2 is equal to 140 degrees. How do we know that? Because there is a straight line, which means that from grade 8, our straight line tells us that angle S1 plus S2 must give me 180 degrees. Right. So how does that help me? Let's put it in here. We've got our 40 over there, and we've got our 140 over there. Okay. Doesn't help us too much there, but where it does help us is, let's look at our triangle over here. Sorry, I just want to rub all this out so we can see. We have an angle of S1, which is 40 degrees. We have an angle of R, which is 20 degrees. We can work out what angle P3 is. Okay. How do we know what angle P3 is? Well, again, angles in triangle equal 180. My maths is telling me that if I add 40 and 20, I'm ending up with 60, which means that angle P2, P3 is equal to 120. Which means that angle P4 and here is all our space disappearing, our angle P4 is going to equal to 60 degrees. Okay. So we keep looking and we say, does that really help me in any way? Let's have a look. Not really. Because if I put all those angles in, if I put all those angles in, I've worked out that angle over there, I've worked out that over there, I've got that angle there, but I need to find out what angle V2 is. Okay, I need to find out what angle V2 is. Okay, I need to find and see. So V2, again, we've actually, whoopsie, I've gone and touched something I shouldn't have. V2, no problems. Earlier we got our arrow theorem, and I'm going to just jump to the left-hand side of the board here. We got V1, we said earlier, that we worked out, we said, sir, V1 was 40. Okay, therefore V2 is going to equal to 180 minus that 40, which is going to give me the 140. Okay, so S2, V2, 140, 140. It's starting to shape up. We're starting to see what we get. And like I said, ladies and gents, there's more than one way to skin a cat. And can you see how long it's taking? Can you see how much time you're going to waste if you use this method? Learn the most efficient method to solve the problem. Okay, right, let's get back into the question and let's quickly get it out and let's solve it. We know that angle P3, we said, was 120. Therefore, angle P2 is also 120. Why? Vertically opposite angles. Therefore, P1 and P is equal to P4. They are also vertically opposite. And how are we going to solve that? Simple. We have a revolution, 360 degrees. You said to me that angle P2 is equal to angle P3, which is P3 is equal to P2, 120. Okay. Which means that, therefore, those angles together, 240. We are going to say 360 minus that 240, 120. Okay. Well, how does that help me? Well, if we have 120 degrees, we're going to divide that by 2 because P1 and P4 vertically opposite, we're going to end up with 60 degrees on both sides. Okay. So what we've worked out so far is we've got angle R, which is 20. We've worked out angle V2, which is 140. I have a triangle, R, T, V. There it is, RTV. And let's just take that out. So RTV, there is our triangle. We said, and I'm going to get rid of all this chicken scratch because that's just all the little stuff that we had a look at. We've got our triangle, so we've got our triangle there of RTV. Okay. We said that we've got R is 20. We've said that V2 is equal to 140 degrees. Therefore, angle T is equal to 180 minus those two together, which is 160. And matriculants, guess what? We get the same answer that we did. Now, I know that I beat around the bush here quite a bit. I went and solved angle S1, S2, and it didn't look like we were getting anywhere. And we were sort of going into a dark tunnel and there was no light at the end. But we did all of that to get to the end. And here is the end. We've got the second way in order to solve angle T. If you'd like me, I would choose the first method. Exterior angles of a triangle, quick, Simple, easy. Going back to the board, please, I'm missing something. I need a reason. Angles in triangle. Okay, and you can say equals to 180 degrees. So can you see that we've used two methods to solve one angle, and they both gave us the same answer. Let's quickly move into 7.2 and let's land this plane. Or as I like to say, let's pull the handbrake up so that we can move on to the next question. The question states, show with reasons that SP, so SPVT, is not a cyclic quadrilateral. Very important. They are telling you, matriculants, SPVT is not a cyclic quadrilateral. In other words, we need to know the properties of a cyclic quad. The opposite interior angles are supplementary. We need then to go and prove that this is the case. And let's go and prove that. And we've actually already proved it. But let's quickly go through and do it again. So very quick, very short, and very to the point. We said earlier that angle S1 was equal to 40 degrees over there. We then said that angle S2 was equal to 140 degrees. Why? That was a straight line. And I can say that similarly, angle V2 is also equal to 140 degrees. Why? Because there's a straight line, STR line. Okay? And you have your arrow theorem. So just some background, V1 would be equal to 40. And there we go. Your straight line is 140. Now we have our two opposite angles, S2 and V2. S2, V2. If I add S2, see, if I add S2 to my V2, I end up with 280 degrees. Therefore, S2 plus V2 does not equal 180 degrees. Therefore, matriculants, SPVT is not a cyclic quadrilateral. Why? Because S2 plus V2 does not equal to 180 degrees. They're not supplementary. It equals to 280 degrees. We've answered the question, 7 marks. I hope that you are on the same page as me and that you have got all 7 marks. Very difficult question. It looks difficult, but it's not that bad. Right, matriculants, that's all that we have time for in this session. We've come to the end of our first question. You can leave your questions and your comments as before, and please don't forget to leave your name of your school so that we can give a shout out to you. Please share, recommend, and subscribe to our YouTube channel. Thank you for watching this lesson, and we'll see you in our next lesson where we'll answer our next question.